Good morning, students. Thanks for watching this video. Just doing a quick recap before we dive right in, and also a reminder that my review sheets for each video are out on the website. You can go to my website, which is linked in the video description, and download those review worksheets, follow along, use them later for reference, however you want to use them. And again, back to the video real quick. It's simply going over the different types of chemical reactions that you'll study in general chemistry and high school chemistry. So I hope you find it helpful. And again, hit like and subscribe if you'd like to be notified when new videos come out on my channel. Have a great day and happy studying. Basic chemical equations. So we have in this video roughly 6 or 7, about a half a dozen different types of reaction types that we'll look at. So as your teacher gets into this particular part of chemistry, they'll start going over the different types. And we just use, for instance, generic letters to represent compounds and elements and so on. So bear with me, you'll see some actual examples here. So the first one we have is combination or synthesis. So when you synthesize something, of course, you bring it together. You take more than one substance and we say, okay, we have a new substance here. So the general form is A plus B. And I'll use our most classic example here of bringing together hydrogen and oxygen to give us good old water, okay? That should be balanced here. So synthesis, right. So those are easy to see because you have multiple elements or compounds on one side, and then you have only one single compound on the other side of the equation, on the right-hand side or resulting side of that chemical equation. Decomposition is just the opposite of synthesis. So we could actually take water and break it down into its constituent elements, such as just simply reversing that reaction here that I put above. And so we have AB is going to split into A plus B. So those, I think, examples 1 and 2 are pretty easy to spot because you have, again, in the first one, you have 2 single, or you can even have 3 single elements or compounds combined into one, and then 2 is just the opposite. You're just taking AB and breaking it down into its parts. So there you have it, combination and decomposition. Now we have what's called single replacement. So the next stop would be, we're going to have, in this case, and it's typically 2 elements or an element in a compound, and we're just going to displace, okay, that's the key part of this particular reaction type, is that we're going to have a displacement. Someone's going to get moved over or kicked out of the picture, basically. So we have 2 types. We have cationic. We also have anionic. So cationic is essentially displacing the cation. Okay, so A is basically going to tell B to move over. We'll have AC plus B. And then on the opposite side, we'll have anionic, where we have X plus BY. And guess what? X is going to take care of Y and move it over. Okay, and so usually, and I'm just going to, come down here real quick. Got it. Okay, so we have some space here for cationic and anionic. I would say, for instance, zinc plus copper chloride. I think we can use that as an example. And then zinc will just displace copper to make zinc chloride plus copper. All right, and then anionic, we could have, we'll do, maybe bromine displace fluorine. So we could have CaBr2 plus F2. Okay. Yes. So this would be your anionic example, where you're taking calcium fluoride, and then bromine comes in, displaces fluorine, or the fluoride anions, and you have calcium bromide plus the fluorine, most likely gas. So those are just generic examples of those types of displacements. Now we have a double replacement reaction. This is where you see basically, and they're going to be ionic compounds, typically in solution. We'll see more examples later in the semester. what we're going to see is we're going to see them basically switch partners. So A will partner with D, C will partner with B. Hopefully you can see that there. A will partner with D, C will partner with B. So basically the cations and anions are simply displacing their respective partners. So let me think of one example real quick. I'm just going to throw out KNO3. That would be your potassium nitrate. Maybe, and I'm not checking to make sure these actually will generate any type of solid precipitate, but what we end up with here is potassium chloride and magnesium nitrate. And I think we would simply put those out there. Yeah, this would be completely balanced. So again, look for ionic substances. You have two ionic compounds and they're simply switching their respective partners once the reaction is carried out. Now we also have what's called a combustion reaction. So combust, you think, okay, we're going to burn, we're going to light up, we're going to burn some kind of substance. So we have what's called a hydrocarbon, which is carbon is combining with hydrogen to make something CH, something CH, several types of those. Remember, carbon combines with, in many ways, with many different elements, but we have CH here. And in the presence of oxygen, we have resulting compounds of carbon dioxide and water. These are fairly easy to identify because the end result will always, always, always be, I'm just going to take care of this here for just a moment. They will always have carbon dioxide and water as the resulting compounds on the right-hand side of the equation. So we can actually break this down into a simple, we'll take methane. Okay. And we always need oxygen too, right? So fires need oxygen to burn, right? And so we have to have oxygen as well on the reactant side. Now, there is actually a special way to balance these. I'll show this in the next video as well, but I'll run through it real quick here. We have carbon, CH4 on the left, and then we have carbon present in the carbon dioxide on the right. I always make sure that the carbon's balanced. And we do actually have a 1-to-1 here where we don't actually need to alter carbons whatsoever. But that's the first thing we need to look at is, are the carbons balanced? Then the next thing we'll do is look at our hydrogens. Well, we have 4 on the left, 2 on the right. So I need to pop a 2 in here. And last but not least, we will go ahead and balance the, here's number 2. And then finally, number 3. So I have 2 oxygens and carbon dioxide, and then 2 oxygens in the water. That's 4 total. So I'll just pop a 2 here and we are all good. But again, combustion reactions are hydrocarbons, carbon, hydrogen. Sometimes there'll be oxygen in there or some other nonmetal, but it's generally CH. In the presence of oxygen will always give you carbon dioxide and water. Okay, it's count on that. All right, so we have one more here. I believe one more. Yeah. So we have acid-base neutralization. This is where we combine an acid with the H up front, and then we have the OH in the back on our base. And when we combine them in solution, they actually, the H plus and the OH, they find each other and form water. So we neutralize it. We neutralize these chemical solutions when we put them together and we get water. Now the BA are just simply the cation and the anion coming together to form a salt. So your teacher will discuss this particular chemical reaction in class, and they should be telling you, okay, once we combine acid with base, we should have water and then its respective salt. And that could be, I think we've already seen, for instance, these are very strong acids and bases here, right? We have hydrochloric acid and sodium hydroxide. We'll combine those to get NaCl and water. All right, so OH is going to find H. Yay. To make water, H2O, and then we'll go ahead and combine. And then there's our NaCl to make a smile. Cute, like how that worked out. So these are the 6 total here. Oh, half a dozen, I was right. And these are the types of chemical reactions you're going to work with in the chemical reactions unit. I'm just going to scroll back to the top here, make sure I didn't miss anything. But again, thanks for watching this particular video. I hope it's helpful to you in getting ready to actually work on more chemical reactions, balancing, and then of course we'll move on to stoichiometry, which is where you actually get amounts of substances and you determine how much is going to result if you carry out particular reactions. So again, hit like and subscribe if you'd like to be notified when more material comes out on my YouTube channel. And again, thanks for watching.